Question 10 is related to the Haber process, the industrial production of ammonia. The equilibrium reaction is given with a delta H for the forward reaction of minus 92 kilojoules per mole. Question 10.1 asks two questions, and notice that there are two here. It says state and explain. So let's say state what would happen to the equilibrium concentration of ammonia if the reaction was run at a pressure of 400 atmospheres. Now, its usual pressure is 200 atmospheres, so if we increase the pressure, then according to Le Chatelier, it's going to shift to decrease the pressure, so it will favor the forward reaction, because on the left there are 4 moles, and on the right there are 2 moles, so it's going to shift to the side with fewer moles to try and release that pressure. So let's start by stating what will happen. The equilibrium concentration of ammonia would decrease. You'd write that in a nice full sentence. The explanation is that according to Le Chatelier's principle, the equilibrium will shift to decreased pressure. Shift to decrease the pressure. You will indicate that there are 4 moles on the left and 2 moles on the right, and therefore the forward reaction is favored to form more ammonia on the side with 2 moles, which will then relieve the pressure. 10.2 asks for an explanation of the horizontal line between T0 and T1, referring to these horizontal lines here. And obviously the number of moles of gas is constant, or the concentration, and that just simply refers to an equilibrium position. So equilibrium has been established. You could call it a dynamic equilibrium is established between T0 and T1. State the change that was made to ammonia in the reaction mixture at T1. Here's T1 over here, and you'll notice there's a sudden spike in the number of moles of ammonia at T1, and therefore the change that was made was that more ammonia was added to the system, or the concentration of ammonia was increased. 10.4, use Le Chatelier's principle to explain why that change had the effect that it did. So remember, the change was that the concentration of ammonia suddenly increased. So the explanation as to why it had the effect is that according to Le Chatelier's principle, the equilibrium will shift to decrease the concentration of ammonia, and it does that by favoring the reverse reaction, and hence the concentration of nitrogen and the concentration of hydrogen. Both of those increase, and if we go back and have a look at that diagram, you'll see that the hydrogen increases and the nitrogen increases as well. 10.5 then talks about a change in temperature. At T3 the temperatures increased from 500 to 900. Asked you to redraw the graph starting at T2, so I'm just going to shift the axis across to there. We're now interested in this part of the diagram over here. You'll remember that the equation is given and the forward reaction is exothermic, so N2 plus H2 going to NH3. Delta H for the forward reaction is less than 0, so the forward reaction is exothermic. So an increase in temperature, according to Le Chatelier, it's going to shift to decrease the temperature, therefore it will favor the endothermic reaction, which is the reverse reaction. So if we favor the reverse reaction, then there's going to be a decrease in the amount of ammonia. So here's our ammonia line here, and there's going to be a decrease in that amount, and then eventually it will reach equilibrium again. Because the reverse reaction is favored, the amount of nitrogen and hydrogen will both increase. Here's the amount of nitrogen, so that would increase and then eventually reach equilibrium, and our hydrogen would also increase and again reach equilibrium. And the question says extend the time axis to time t4 at which the equilibrium is re-established, so we could indicate that time axis there. That would be t4.